Good morning, everybody, and welcome along to the Ametek Solidstate Controls Increase Reliability by Performing Maintenance webinar today. Hopefully this is the webinar that you were expecting. If not, stick around. You might learn something, or you might find something interesting anyway. Hopefully everybody can hear me okay. If you don't mind, post in the chat bar to let me know that you can hear me. If not, we'll see what we can do. And I'll just get some formalities out of the way while we're waiting for everybody to join the room. So first of all, my name is Craig Williams. I'm the Senior Technical Manager for Ametek Solidstate Controls, and I work out of the Stafford office just south of Houston in Texas. I have 20 years in the industrial UPS industry. Basically, half of that was in the North Sea oil and gas platforms off of the coast of Scotland. Thank you for letting me know you can hear me. And the other half of that was basically in the Gulf Coast region of the United States, mainly in Texas and Louisiana. I've worked with all major UPS and charger manufacturers from all over the world, so I'm very familiar with all of the UPSs that are available out there. There will be a lag of around 30 seconds between you hearing my voice and me seeing a question or you answering anything that I have asked. It's just due to webinar technology. It has to process this and then turn it into a signal that can be seen on your iPhone, on an Android phone, web browser, iOS, all that kind of stuff. So there is a 30-second delay between you hearing my voice and me seeing a question. The software that we use for our webinar is called Webinar Jam, and it seems to be the best service out there. And the good thing about it is it has a panic button. Don't get alarmed. All that means is that when, if for some reason the webinar crashes, then all I have to do is press this panic button and Webinar Jam automatically creates a new room and invites everybody back into that room, and we can continue where we left off. Okay. A question that is asked all the time is, will the webinar be recorded? And yes, the webinar is recorded. It's automatically recorded by Webinar Jam, and also that Webinar Jam recording is, if you have registered, that link will be available to you at all time. But the minor problem with that link is it treats it as a webinar every time that you play it. So you don't get to fast forward and you don't get to rewind. And the reason why it does that is if somebody watches it again, they can type in a question or a comment at the relative time of the webinar that they're watching it. And actually, I get an email to let me know that somebody has asked a question from the recorded webinar. So it does have a purpose, but obviously a lot of people like to fast forward and rewind. So what our marketing department do is they download the recording and turn it into an MP4 file and put it on YouTube, and everybody will get the link that attends the webinar today. And the webinar should last around 1 hour. It could be quicker. It just depends on how much I waffle on, and I tend to do that sometimes. So I will try not to do it too much today. Okay. So what we're going to discuss today is understand why you should perform maintenance, understand what maintenance should be performed, and then understand why the recommended maintenance time intervals were created for our UPS systems, and then discuss the use of the specialized equipment during maintenance. And one thing I did forget to say, if you do ask a question, I tend to save the questions to the end of the webinar because of the 30-second delay. But if you do ask a question and I see it and we're still talking about that topic, I will try and answer it at the time. You just type it in the chat bar and we'll see what we can do. Okay, so the first question is, why do we perform maintenance? And the simple answer to that is reliability. All UPS systems are attached to extremely critical loads inside a plant setting, and you want as close to 100% reliability as possible. Now, when I ask that question, why do we do maintenance? A lot of people will say, well, because SAP prints out a work order every month to tell me to do my monthly checks or to do my annual checks. And that's all basically goes back to what a reliability engineer does. And believe me, I am not a reliability engineer. I really respect what those guys do. But there is some data behind why you should do planned maintenance with respect to reactive maintenance. And the main thing is, the more uptime you have for your piece of equipment, the better your safety record can be, because obviously if you have an unplanned shutdown of any piece of equipment, then people are running around in a panic. We all know that unplanned shutdowns always happen on Friday night at around about 10 o'clock. Don't know why, but or at the weekends. And people come into the plant, they're running around trying to get things fixed. And obviously that can cause safety hazards. But with planned maintenance, you can plan it and you can get your permits in place and people are more calm. So it really helps out on safety. And obviously the uptime of your equipment saves the plant money as well. And this is a lot of reliability engineers will recognize this curve. And basically there's three curves there. So the green curve is the total cost of maintenance. That's planned maintenance plus corrective maintenance. The red line is planned maintenance, and the blue curve is corrective maintenance. And that sweet spot right here in the middle here, between those two dotted lines, that's where you need to be. As you can see, the planned maintenance line goes up here. And once the cost of planned maintenance versus corrective maintenance gets into that sweet spot, that's when you save the most money. So that's the optimum PM frequency for your equipment. So there is some science behind all of this. Now on this slide, on the left-hand side of the chart there is a challenging example, and that is, say, a maintenance shop that does mostly reactive maintenance. And in this slide here, it shows that 64% is breakdown maintenance and 36% is planned maintenance. And then on the right-hand side, that should be your goal. Most people say that 80% of your maintenance should be planned and about 20% breakdown. That's really what you should be aiming for. And the interesting thing on that is, that's taking into consideration that one planned maintenance hour is worth 2 breakdown hours. Now, there is some debate about that. A lot of people think that one maintenance hour is worth closer to 3 breakdown hours. Because if you plan something, you can have the machine operators in place. You can assign all of the people that need to be there ahead of time. And the ripple effects on the machine being shut down in a controlled manner downstream can be managed much better. So there's a huge amount of savings if you do planned maintenance. And this chart here actually shows that quite well. So if you see at this top line here, the total hours is 100 hours. And going back to that chart we had before, the unplanned was 64 and the planned was 36. Okay, so it's saying percentage planned work here is 36%. And with every hour we increase, planned hour, we increase by 1, we are saving basically 3 unplanned hours. Okay, so as you go down to the bottom here, we are now using a total of 66 hours, but we're accomplishing the exact same work. So we're saving 34 hours by doing planned maintenance, and we're getting to the 80% percentage planned work that we're trying to get to. So doing planned maintenance can save you money, it can save you hours, and it allows you to assign your technicians to do other things. So once again, there is science behind it. And of course, why perform maintenance on a UPS? Well, the UPS is the last line of defense. A UPS is always connected to absolutely critical loads. That's the inherent design of the system. And if the UPS fails unexpectedly, in most cases, unfortunately, the production of the unit must be shut down. And that cost can be millions of dollars. An example of that is, say it's a 24-hour, 365-day-a-year plastics plant, and they're extruding plastic to their extruding machines, and the plastic is being made at the plant. If the production stops and the flow of the plastic stops through the pipes, that plastic goes hard and it plugs. And in some cases, you've got to go out and you've got to cut pipes, weld pipes, and the plant could be down for maybe 24, 48 hours. And that is a huge cost hit. And it could be a huge safety hit as well because of all the other work that is caused by it. So that is why it's important to keep your UPSs up and running as much as possible. So, what maintenance should be performed? Well, really, that depends on the failure modes. And what we did when we designed the maintenance schedule for our UPSs is we looked at the main failure modes and made sure that we were taking care of the things that could happen. Okay. So the first failure mode I'm going to discuss today is high resistance connections. Okay, and they can be caused by poor contact pressure. In other words, inadequate torquing of the bolts. So when you land a cable, you don't torque down the bolt properly and you have a loose connection. It could be insufficient pressure in the compression lug. In other words, the lug wasn't made correctly. And you can see on the left picture there that lug, I don't care what anybody says, but that has not been made correctly. You can see that some of the strands of the cable have been cut. And if I had to guess, that lug is not the correct size for that cable. And they've had to try and trim some of the strands so it can fit inside that lug. So poor mechanism pressure can cause high resistance connections. And the other one is deficient contact surfaces, either dirt or corrosion or something else between the contact of two electrical conducting surfaces. And you can see once again in that picture on the left that there is some green corrosion, probably caused by water ingress into that system. And once that corrosion builds, you can see it here. If that corrosion was found on this surface, then that would cause a high resistance connection between that lug and the mechanical surface of what it's being connected to. And that can cause high resistance. And what's the problem with high resistance connections? Well, high resistance connections cause voltage drop, which then cause heat with power dissipation. And you can see on the right-hand picture there on that small circuit breaker that there has obviously been a loose connection on this circuit breaker, and it's been there for a while, and with current flowing through that connection, the power dissipated has been very high, and it has caused a severe amount of damage to that circuit breaker. Now I would guess that this is probably, it looks like a very small circuit breaker, maybe 10 maybe 15 amps, and just say that was, you know, our UPSs go from 10, 15 kVA up to 200 kVA. So we have a much larger amount of current flowing through our power connections. So we can cause a lot more damage by high resistance connections. Okay. So that is one mode of failure, is high resistance connections. Well, how can we prevent that? Well, all of the Ametek solid-state controls field service guys, absolutely every single one of them, carry a FLIR C5 infrared camera, okay? And it is an industrial grade infrared camera from one of the most renowned makers in infrared cameras, FLIR. And here's a prime example of what they find. Every PM that one of our guys performs, they have to take pictures inside the UPS of certain components to look for high resistance connections. And in this connection here, in this picture here, they took a picture of the AC capacitors inside the UPS. Now, this actually was a system that had been in service for a couple of years, and we went out to perform a PM once we had initiated the FLIR cameras into our service operations. And this problem had not been caught the year before because we hadn't been checking for thermal imaging. And in this circumstance, you can see in the middle there that this red triangle here is pointing at the hottest part of this machine. That is not supposed to be that hot. You can see here basically what the temperature should be for a normal capacitor. And as you can see, the maximum temperature there is 96.5 degrees Fahrenheit, which is 20 degrees above the average, approximately. So what the field service technician did was he powered the system down and had a look to see what was wrong with the connection. And he found the connection wasn't connected properly to the capacitor spade terminal. What he found was it had been installed between the plastic collar and the spade terminal itself. So it was still making connection, but it was a high resistance connection. And you say, well, it was still in circuit, so what's the problem? Well, that heat is a problem. It's going to eventually damage the insulation of the cable. That heat is going to migrate into the capacitor, and we'll find out a little bit later that heat is the number one enemy of capacitors. It causes the capacitor to lose life. So that heat would have prevented the capacitor from reaching full life and would have caused a premature failure. So a good example of a failure mode being caught by preventative maintenance. And remember, that's really what we're trying to do with preventative maintenance. We're doing maintenance to try and prevent something happening that may cause an unplanned event in the future. And then the opposite of a high resistance connection, in this picture here, it's difficult to see to start off with, but this was actually on a UPS that had just been commissioned. It was a 250 kVA UPS. And on our big UPSs, we have multiple cabinets that need to be bolted together, and the connections between the cabinets need to be bolted together. And that's usually done by the contracting electricians for the plant. And in this circumstance here, when we went to check it out after we had started it up, in these three boxes here, we have a choke or an inductor in each box, okay? And as you can see, the bottom inductor is hot, the middle inductor is hot, but the top inductor is not. And this is actually kind of the opposite of what I just spoke about in the previous slide. All of these inductors should be relatively warm because they dissipate heat when they are in operation. Transformers and coils, due to their inherent nature, they do dissipate quite a lot of heat. So that top choke should have been the same temperature as the bottom two chokes. So once again, the FSE shut down the UPS in a controlled manner, investigated what had happened, and found that a connection had been made which basically bypassed that top inductor from a circuit. The UPS still operated, but it was operating out with its design, and it would have it only got caught by performing a thermal imaging scan. So a great example, two great examples of why performing thermal imaging in a UPS or any other piece of equipment is extremely good practice to find things before they become an actual issue in the future. So the next failure mode is dust. An IEEE study showed that 18% of switchgear failures listed dust as the main contributing cause. Okay, 18%. Now, I didn't have any information for UPSs, but I'm guessing it would be relatively similar. And the common impact to current carrying equipment and systems which are exposed to dust is short circuits and arcs. An example of that, I don't have any pictures of it. I remember a UPS that was on a platform in the North Sea, and it was more a commercial type UPS. It was probably not where it should have been installed. And that UPS basically had a fan on the front of it that pulled in air directly across the main circuit board and the heat sinks for the power transistors, and then out the back of the UPS. And there wasn't any filtering on that UPS whatsoever. And it just so happened there was an air intake very, very close to where that UPS was. And the North Sea, I'm guessing you've never been there before, but it's extremely wet. It rains a lot. It gets foggy. It's very humid, and it's not a nice area. And what had happened was that air intake duct was pulling in not only dust from the room, but moisture from outside. And what happened was, after a certain amount of time, the dust built up on the board. That dust got moist and eventually caused short circuit arcing and completely blew the main control board for that UPS and caused the UPS to shut down, drop the load, and caused the DCS system to lose all of its screens, and the whole platform had to shut down because of it. So dust and other things getting into the system is extremely important to prevent. So every year, if you do your full maintenance during our annual PM, every FSC that we send out, it includes a thorough cleaning of the system to remove all dust and debris. And we also comment on every report what type of room the UPS is in and if there is any problems. So dust is actually very, very important to clean out. So another mode of failure is relays. So every time the contact of any switch, and obviously a relay is just an electromechanical switch, there is a certain amount of contact wear. You can see in the picture on the left there that that's a perfectly brand new relay, and the contacts are clean, beautiful. That's what your contact should look like. And the picture on the right is what the exact same contacts look like after being in operation for a certain amount of time. Now, obviously, it depends how much they open and close, but every time any contact opens and closes, there is always going to be a small arc, because you're interrupting current or you are closing in on current. There is always going to be an arc, and it pits the surface. It can cause build up on the contact surface, and eventually it's going to cause either a high resistance connection, or it's going to cause a situation where the connection doesn't get made at all. So it's extremely important for critical relays in any system, never mind a UPS, that if it is critical to the operation of your plant, you should be changing your relays on a very frequent basis. And what we recommend is that every year, if you're going to get a PM done by one of our field service guys, all the critical relays inside that UPS will be replaced. Okay, it has to be critical to the normal operation of the system. I'm not talking about alarm relays or something like that that just gives you an alarm. All the critical relays to keep the inverter on load circuits with the battery backup, all of those should be replaced on an annual basis. Okay. Once again, there's always a good reason for why we recommend what we recommend. So the next mode of failure is capacitor failures. Now, you can see in that picture there, this is what the bus bars should look like. They should be absolutely straight and even. This bus bar here should be going over here, and you can see that this capacitor here, surprisingly enough, should not look like that. That has been a sudden failure of that capacitor, and capacitors usually fail due to age and temperature. Okay, and especially DC electrolytic capacitors, which is what this capacitor is. And a DC capacitor is very similar to a short-term battery. It has electrolyte inside of it, and they are sealed, and that electrolyte is supposed to remain in the capacitor at all times during its life. But what happens is, if the capacitor is heated up above its normal temperature range, that electrolyte within that capacitor will eventually dry out, because each capacitor has a valve on the top of the capacitor to let pressure out. And in letting pressure out, it will let some of the moisture within that electrolyte out. And then eventually what will happen is, when the electrolyte dries out, there will start to be short circuits inside the capacitor, and those short circuits cause heat, and heat builds up pressure. And it's like a snowball effect. And eventually what will happen is when a DC capacitor fails, it fails with so much pressure that it can do what you see in this picture. It will completely rupture in an explosive form. And I can pretty much assure you that there would have been a huge amount of smoke from inside the capacitor when this capacitor failed. You can see on this capacitor here, there has been some contamination due to the capacitor failing, and that can get on control boards and go all over the UPS as well. So capacitor failure is something you really, really want to stop. And obviously it's going to stop the operation of the UPS. So capacitor manufacturers list the anticipated life of their capacitors in hours on their datasheet. And the anticipated life is based on certain parameters. And the three main parameters are voltage, temperature, and ripple current. Okay. So if you operate the capacitor at temperatures above the maximum rated temperature given by the manufacturer. So let's just say, for example, they say that 50 degrees Celsius is the highest temperature that they want that capacitor operated at to give you its calculated lifespan. Then the life of that capacitor will decrease by half for every 10 degrees Celsius above what it says on the data sheet. So in that circumstance that I just told you, the 50 degrees capacitor, if the temperature of the system went up to 60 degrees, that capacitor's lifespan has been halved. Okay, so it's very, very serious. And also the life of the capacitor can be increased or decreased by the ratio between the rated voltage and the applied voltage. So say, for example, a DC capacitor is rated at 300 volts DC, and you run it at you apply 300 volts to that capacitor, then you will get the expected life out of that capacitor as per the data sheet. But if you put less voltage on that capacitor, let's say you only put 150 volts on that capacitor, then you are gaining life. Okay. And with all of these parameters taken into consideration and then entered for the spec of our UPS system, then the design life of the capacitors that we install, the main DC capacitors within our UPS, the design life turns out to be 10 years if you operate it within the parameters on the data sheet of our UPS. Okay. Now, once again, we can do a thermal scan, which we do, and you can see in this picture here that we have a row of DC capacitors here, and they are all the same temperature. Okay, you can see here that there is something that's hot. That is the discharge resistor that's connected across the DC capacitors. We know that that should be hot. It will dissipate power all the time, but we can see there is no capacitors here showing any signs of excess heat. So that's another good way to show that the capacitors are within the tolerances. Somebody's asked a question, DPP, what does that mean? DPP means digital process power. It is our digital UPS. Somebody else has asked, are there any critical relays in the DPP product? There are no critical relays in the DPP product that need to be replaced, as far as I can recall. In fact, I should say, no, there are not. It's only in the microferros that we have critical relays and the old analog systems. So thanks for those questions. So another mode of failure is heat stress. The US Air Force Avionics Integrity Program did a study, and they found 50% of electronic equipment failures were caused by high temperature. That's a huge amount of failures. Okay, and it kind of actually goes back to the capacitors that we just discussed there, because heat kills capacitors. Okay, so all of our UPSs have been designed in such a way where we know how much air we need to get out of the system to make it run at the temperatures that we have designed. So we will have fans on the heat sinks for the power semiconductors for the SCRs and for the transistors. And if it's a bigger UPS, we will also have fans on the top of the UPS to pull even more air out, because there's going to be bigger transformers. Magnetic transformers do dissipate a lot of heat also, and we need to get that air out of the UPS so it doesn't heat up all of the components inside the UPS and cause premature failure. So the flip side of that is those fans are relied upon to get the air out, so they have to be maintained. And the fan life is once again defined by the manufacturer in hours of operation. And we went to our manufacturers and we asked, how long will the fans last? And it was calculated at 5 years if the temperatures stay within the tolerances of the UPS. So that's why we always recommend that the fans are replaced every 5 years. We need to make sure that the fans get the air out of that system. Okay. Printed circuit boards can fail. There's absolutely no doubt about it. And there's once again, it goes back to the capacitors. This is a rectifier control board for one of our UPSs. And you can see on the bottom right here, there is a DC electrolytic capacitor there. And what a lot of people don't realize as well is these little yellow capacitors here are tantalum capacitors. And there's another one there as well. And tantalum are basically an electrolytic capacitor as well. And all those capacitors are affected by age and temperature. So therefore, they still have to be replaced as per the manufacturer's guidelines. And the guidelines for printed circuit boards are 10 years because of those electrolytic and tantalum capacitors. So faulty capacitors can seriously affect the operation of the UPS. They're usually used in power supplies on control boards and for other circuits within the UPS. And if they fail, they can cause unpredictable operation of the UPS and can cause you to be in bypass when you don't want to be in bypass. And then if you do have an AC power failure at that time, you will drop the load. So we always recommend that the circuit boards are replaced every 10 years, but that is mainly due to the capacitors, the DC electrolytic capacitors on those boards. And in passing, I'm going to also discuss another mode of failure to do with the remote manual bypass switches. Now, obviously, we've had a huge amount of experience. We've been making UPSs for nearly 60 years now. And we're very familiar with doing maintenance on our UPSs. And we have found in many circumstances that plants that don't operate their maintenance bypass switch on a regular basis can have issues. We have found on many, many times that if we go to a UPS that hasn't had the maintenance bypass switch operated for maybe 5-10 years, that in sometimes that switch will not even move. It will not allow us to put that system into bypass. And the other thing about the rotary switch inside our manual bypass switches is they have a mode of operation designed by the manufacturer to clean the surfaces of the contacts each time that switch is moved. So here's a technical response from ElectroSwitch. They are the manufacturer of the majority of our rotary bypass switches. And they said that many customers will, as a rule of thumb, operate or exercise the switch at least once a year. And he goes on to say, as you know, there is a unique dual wiping, self-cleaning blade and terminal interface, which helps maintain a low contact resistance over the life of the switch. So therefore, by operating the switch periodically, the customer is cleaning those interfaces of any dust, debris, or oxidization that may have formed on the surfaces. So basically, the manufacturer is saying it's good to move your bypass switch on a regular basis. And basically once a year is okay for that because it does clean the contacts. The last thing that you want is to have a bypass switch, say it's in a relatively industrial corrosive environment where there's maybe H2S in the air, okay, and you don't move that switch for 10 years, and then you have an instance where the UPS has failed to static bypass, and you want to do some work to get that UPS back up and running, but you have to put the system in remote maintenance bypass. You could, in theory, when you go from the normal position to the bypass position, because that corrosion caused by the H2S has not been cleaned off by regular exercising of the switch, there is a possibility that when you move that switch, the contact from the make before break doesn't actually make when you move it, and it could, in theory, drop the load. So the manufacturer does recommend that you do exercise your switch on a periodic basis. So our recommended PM periods here at Ametek Solid State Controls, we have 3 types of recommended PMs, okay? And this first one here is the PM1. This is our annual PM. And I'm not going to go through absolutely everything, but it lists what we do. And I just wanted to touch on a few of them to tell you actually why we do it. So we do check and record all the voltages and currents within the UPS. And we don't just do it for so we can put it in a fancy report. We do it because we're checking it against the tolerances of the system to make sure that everything is okay that's being applied to that system. Make sure that the 3-phase AC input is within the tolerances that are allowed, that the bypass input is within the tolerances allowed. We're checking all of these things. Another thing that we do is we check the input current to the charger bridge for balanced currents. Now, a lot of people don't realize, but the secondary of our input transformer to our charger bridge is a delta connected transformer. Sorry, the primary. But the main point is the currents on that rectifier should be balanced. So on A phase, B phase, and C phase, let's say A phase is 10 amps, then B phase and C phase should be 10 amps. And if there is an unbalanced current, that shows there's an issue with the charger bridge. Maybe there's an SCR that is not firing, or there's a loose connection between the gate driver board and the charger bridge. We'll find that very easily by checking the current. The other thing we do, when we check the voltage and currents on the UPS, we are then calibrating them to either the analog or the digital meters. We're not just taking the readings, we're making sure that the meters on that UPS reflect the actual value that is being seen by the UPS. Now, at most plants, you'll have the operators go around on a daily or a weekly basis, checking all of the meters on your critical equipment. We've all seen it. You've got the pencil or Sharpie mark on the meters to tell you what they should be. Well, those readings are useless, absolutely useless, if they're not reflecting what is actually being seen by the UPS. So you have to make sure that when you're checking all the voltages and currents within the system, that you are comparing them with what the digital or analog meters are saying on the UPS, so you know what's going on. We also recommend that you check all of the alarm set points inside your UPS. You have to make sure that your alarms are going to work correctly, just in case they are needed. So during the annual PM, we do all of that. Another important point is the free running frequency of the inverter. Now, a lot of people will say, okay, but you check the output of the UPS and it's running at 60 hertz. That means it's fine. Well, that's not actually true. We have 2 circuits within the synchronizing circuit of a UPS. One, when you have bypass available, it will synchronize itself to the 60 hertz signal from the bypass. When the bypass voltage and frequency is lost, then what happens is the inverter starts running on its own internal clock. It actually has a quartz crystal inside the control board that is designed and set up. If it has no external signals, it will run at exactly 60 hertz in America and obviously 50 hertz in some of the other international companies. And those 2 circuits are different. So we always test the free running frequency of the inverter to make sure if you do have a bypass failure, that it does operate still at its correct frequency. We check thermal couples to make sure they shut down the system as they should do if there was an over temperature occurrence. We verify the AC caps are functioning. We test ripple current on the battery, and we check that it's less than 5% of the ampere rating of the battery. And then we do any other functional test deemed necessary by the service engineer. And for the inverter static switch, every single one of our FSEs also carry an oscilloscope. And what we do is we capture the transfers between inverter to bypass on the static switch and bypass back to inverter. And in the annual PM, we will replace any components that have a low life. And that includes pilot lights if they are incandescent and the critical relays that I mentioned earlier. Then we have the PM5. So every 5 years, we do everything that's included in the PM1. And then we also recommend that you replace the pilot lights, the fuses, the fans, and the relays. Okay, so it's just mainly the fans are the most important thing during the PM5 because of the design life of the fans from the manufacturer. And then the last maintenance schedule we have is every 10 years. Okay, a PM10. So that includes everything in the PM1. It also includes replacing the critical components, and that includes the capacitors, the pilot lights, fans, alarms and relays, and all of the circuit boards within the UPS. So it's pretty much you're ripping out the inside of the UPS and you're replacing all of the age-degrading components to make sure you still have a good UPS that's going to work for you for many years to come. Okay, it is much more intrusive, but it does make sure your UPS is back up to as if it was straight out the factory. And we do offer optional services. We have the ability to do battery capacity tests, system AC load testing. Many customers ask for that, especially after a PM10, because you are replacing so many components within the UPS. A lot of clients like to have the UPS tested before they put it back on plant load. So we have a wide variety of AC load banks that we can send out and test the UPS before we put it back online. It's a very common thing for a common additional service that some of our customers want. And we also do transformer replacements, the CVTs, the constant voltage transformers, which are installed in our microfarrow and our old analog UPSs. Okay. Now, this is all the equipment that is standard for all of the Ametek solid-state controls FSEs are out there in the field. Every one of our FSEs carry one of these pieces of equipment. So you can see we use a Fluke 87 true RMS volt multimeter. Every person carries a Fluke 190 2-channel oscilloscope. They carry a Fluke i410 minimum. They usually carry another amp clamp with them as well to measure current. As discussed earlier, they carry a FLIR C5 thermal imaging camera, and they all have a laptop so they can connect to each of those devices as necessary. And the reason why it's important for an oscilloscope to be used when performing maintenance is we're looking at waveforms within the UPS. Now, here's a prime example. This is a charger output of one of our UPSs before it gets to the filter circuit. And we know what that waveform should look like. On this example here, this is a 6-pulse, a 6 SCR charger. Okay, and it's a 60 hertz system, so 6 pulses at 60 hertz will give you 360 hertz. So we know just by taking this oscilloscope picture that that charger is working correctly. Now, if there was a pulse missing here, for example, because let's say the gate lead to one of the SCRs had come loose and one of the SCRs wasn't firing, the charger would actually still work. Our chargers will still work with one SCR taken out of circuit as long as it's an open circuit. And you're not really going to see the detrimental effects of that until you put full load on the UPS, which is very rare to load a UPS up to full load, or after you've done a battery capacity test and you're putting the batteries back on charge. So it's extremely important we see that. So somebody's asked, while I'm talking about SCRs, what is the life cycle of the SCRs? From the manufacturers, they say there is no degradation over time. So remember, we always base our maintenance on what the individual manufacturer of that part says. So the manufacturer does not recommend that that part is replaced at any time interval. So therefore, we do not recommend that the SCRs or the transistors are replaced at any point. We only recommend they are replaced after they fail. Okay, so that's a good question. Thank you for asking that. Another waveform that we take is synchronization. We want to check that the bypass and the inverter are synchronized together. And we take this reading before we start our maintenance on the UPS, because obviously the UPS has to be synchronized for us to get it into bypass and perform the maintenance. And what we want to see is what you see here, that the red and blue waveforms are perfectly matched up. There's only 4 electrical degrees, as you can see here, between the 2 waveforms, and that's absolutely fine. We know that this UPS is okay to be transferred to bypass without any issues. And one of the most interesting readings that we take with the oscilloscope is the transfer from inverter to bypass and from bypass back to inverter. Okay, so what we do is we put an amp clamp on the bypass input to the static switch. So when the UPS is running on inverter, there is no current flowing into the bypass, and that is what this blue waveform is here. You can see there's no current. The red waveform you are looking at here is connected to the output voltage of the UPS. Okay, so this portion of the waveform here is the output of the system before it was transferred to bypass, and this red waveform here is the output of the system after it was transferred to bypass. Because you can see at this point here, that is where our technician pressed the bypass to load push button on the front of the UPS, and the system transferred to bypass. How do we know that? Because current started flowing on the bypass cable. So we know that is the exact point that the system transferred from inverter to bypass. And as you can see with the red waveform, there is absolutely no chinks or dips in the voltage. That transfer took place without any issues whatsoever. So it's a very important reading that we take. Okay. And the one last thing that an oscilloscope can do is it can give you mathematically calculated total harmonic distortion readings. Okay, so on the left here you can see we have the voltage and current from a UPS. The red is the voltage, the blue is the current, and what the software within the Fluke 190 allows you to do is you can create this graph here, and it tells you right here what the total harmonic distortion of the voltage out of the UPS is. And on this circumstance, it's 1.17%, which is well within the tolerance of our UPS. If that started to go up, we may have a problem with the capacitors in the filter circuit or something we could look into. So it's an important reading to look at if you're having issues with total harmonic distortion. Okay. And I just wanted to make sure everybody knew that when we send a field service guy out to anybody's plant, every single one of our field service guys adhere to the NFPA 70E safety regulations, and we send them out there with Category 2 PPE. So that's a minimum of 8 cal fire retardant clothing, and they have the arc fast shield, balaclava, and we send all of our guys out with voltage rated gloves as well. So all of our guys, all and girls if we had them, all apply the NFPA 70 regulations apply to all of our guys, and they all conform to it. What's the maximum allowable total harmonic distortion, somebody has asked. That's a very good question, and I knew somebody was going to ask that, and I should have researched it, and I cannot remember at this time. So what I will do, Aaron, is I will check back with you and I will get you the answer. So I'm thinking it's either 3 or 5%, but I'm going to take a note of that and I will promise to get back to you. It says here also to check the terminal temperature, any fluke infrared imager can be used. Yeah, absolutely. Yeah, no, it doesn't have to be a C5 camera. When you say fluke infrared imager, what I would say is there are a lot of people out there who use the infrared gun type things that shoot out a laser and it gives you a digital reading on the screen of the gun. I don't like those because you don't get to see what you're looking at. And if you know, most technicians will just go in, wave it around a little bit, and you might not find what you are looking for with one of those. I think in your question, you say an infrared imager. Yes, absolutely. I agree. If it's an imager, you're taking a picture and it's a proper thermal image, then yes, that is absolutely good to do maintenance on your UPS and other equipment. And the last thing, I don't want to get salesy. I hate trying to be a salesman, and this is not what I'm trying to do here. But what I wanted to show you was the benefits of regular Ametek maintenance. So if you buy a UPS from Ametek Solid-State Controls and you install it, and after a year you perform the recommended PM schedule using Ametek Solid-State Controls, a lot of people don't realize this, but you get a full bumper to bumper extended parts warranty on that UPS. Labor is also covered. Travel and living expenses are charged at cost. But basically, if every year you get an Ametek SCI field service guy out to your system and perform the maintenance, you get an extended warranty for the life of your UPS. And I mean that, up to 20 years, even past 20 years, you get a full bumper to bumper parts warranty. So a lot of people say, okay, Ametek Solid-State Controls, they are a little more expensive than a lot of people out there who do maintenance on UPSs. Yes, we are, because we have to build in the warranty costs into that PM as well. So, you know, our control boards are not cheap. So if after 10 years, let's say at 9 years, you have a failure and you've been performing the correct maintenance schedule using SCI, then if a board fails, we will come out, we will give you that board free of charge. That could be between $5,000 and $10,000. And you will also not have to pay for labor. So that is something a lot of people don't understand about using Ametek Solid-State Controls technicians to perform the maintenance on your UPS. We give you a full warranty on that system. Okay. And the last thing is there is another level above just performing the maintenance as per the recommended schedule. We offer what is called a comprehensive service agreement. There's 3 levels. The most popular level is the one in the middle called the CSA, the regular CSA, this one here. Okay. And what happens is these can be 3, 5, or 10-year contracts. And what it does, the most important things that it covers are here. The emergency service fee is waived. You have a guaranteed response time of 72 hours. There is no minimum service cost for a repair. All the parts in the system are covered by warranty. The transformers inside the system, if they are less than 20 years old, they are covered. You know, and transformers, constant voltage transformers are extremely expensive. They are covered under the CSA. Traveling and living expenses are covered. Everything is free. Now, there's 2 advantages to that. And the first thing is, let's say you do a a 5-year CSA contract with us, and within those 5 years, the PM10 is due. That is the really expensive PM. Well, what that does is it allows you to spread the cost of that 10-year PM over the 5 years, along with the annual PMs. So it makes it a lot better to budget for. Okay, and the second thing is it allows your maintenance department to know how much the maintenance of your system is going to cost. You don't have to issue a PO for a repair in the future. You know that for those 5 years, the cost to keep your UPS running and maintained is going to be that cost over 5 years. So it's a very, very good way to annuitize the value of the maintenance over a period of time. Okay, so obviously I work for Ametek Solidstate Controls. I say it's a very good thing to do, but it does have its benefits for maintenance and planning departments. Okay, so I think that is about it. One thing I wanted to do before I get to questions is show you something that we have just introduced to our field service team. Basically, we're always looking at ways to make our UPSs more reliable. We're always looking at ways to make our service guys get their first time fix rate as high as possible. And what we decided to do is we now work with the guys at HELPlightning. It's a merged augmented reality app. And what they do is they have a video. I want to show you the benefits of this. At this moment in time, we're only using it between the technical managers and the field service guys, but we are planning on rolling this out to our CSA clients sometime in the future as well. And hopefully you can see the benefits of what HELPlightning may bring to a situation at your plant. So I'm just going to play the video now, and I'll be back after about 3 minutes, okay?
At HELPlightning, we are reimagining the way industries give and receive help. This patented technology uses merged reality to create a virtual interactive presence. Virtual interactive presence is the merging of two real-time video streams, blending a remote expert with a local person needing assistance into a collaborative merged reality environment. Reaching beyond the limitations of simple video and audio calls, HELPlightning's interactive help sessions accelerate and simplify problem diagnosis and resolution. Simply put, experts can be hands-on and virtually reach out and touch what their customer or service technician sees in their field of view. They can telestrate, freeze images, use hand gestures, share pictures, or even add real objects into this merged reality environment. Almost every business can benefit from this extraordinary method of delivering help. The Software as a Service solution is available as an Android, iOS, and web browser app, and it can be integrated into existing customer care and field service processes and systems. Through virtual interactive presence, you can provide quicker response times and problem resolution, dramatically improving customer satisfaction. Remote experts can instantly diagnose, solve, and validate customer care issues, even from thousands of miles away. With HELPlightning, you can be there instantly.
So hopefully you can see the benefits of how that is going to help us if one of our technicians has an issue at site and we're trying to help troubleshoot the issue. Then you can see how that has become an important tool if obviously you have internet connection or they have cell phone service at the site. And we're obviously dealing with those issues as we speak, but we've seen some good results from it already. So look out for more on that over the next few weeks and months on our social media. So that is pretty much it now. I hope you enjoyed it. So now I'm going to open it up to any more questions. So I'm going to look here. We see, which is more reliable, IGB rectifier or thyristor rectifier? Well, that's a very good question. And over my 20 years and with many other people who have worked in this industry for a very long time, our opinion is you cannot beat the reliability of an SCR rectifier. SCRs are the most robust devices that you can get out there. They take a huge amount of abuse before they fail. IGBTs, on the other hand, are extremely sensitive. They're very, very sensitive to high currents. You can put a high current through an SCR and it's not going to damage it. You'd have to put an extreme amount of high current for a prolonged period of time through that SCR above its rating to make it fail. With an IGBT, if you put high current through it, it's going to fail pretty much every single time. And you cannot protect an IGBT with a fuse, okay? It's impossible. The IGBT will blow way before the fuse blows. With an SCR, the fuse is going to blow every time. If you use a semiconductor fuse, the fuse is going to blow every time and protect the SCR. So in answer to your question, an SCR rectifier is, a thyristor. SCR and thyristors, they are both interchangeable terms. A thyristor rectifier is far more reliable than an IGBT rectifier. Do you recommend to conduct 5-year PM tasks by customer when they have confidence? We don't have an issue with the customer conducting a 5-year PM, okay? The reason why we always encourage you to use the Ametek Solidstate Controls FSE to perform that maintenance is to maintain your bumper-to-bumper warranty, okay? We want you to rely on your system. And if you have that warranty, you know basically how much your system is going to cost you every year to maintain, because you don't have to pay for anything else. So yes, if you are confident to do it, absolutely you can go and do it, but then you will not have the extended warranty that comes with an Ametek FSE field service guy doing it. So if you see rust on the outside of an AC capacitor on less than 5 years old equipment, especially in humid environments such as steam generation plants, is that okay to live with? I suppose the answer to that question is it kind of depends. The casing of the capacitor has absolutely no interaction with how the capacitor actually works. So I would say in most cases it is okay to run with capacitors that have rust on it. But to me, it indicates that there is going to be an issue in the future. If there is rust and you know it's a humid environment on the capacitor, then other surface areas within that UPS are going to start to see rust and other effects of the humid environment. So the answer to the question is, it's not going to affect the capacitors, but I would suggest that they look into either putting the UPS in a temperature and humidity controlled environment, if possible, which I know is difficult in steam generation plants. They usually put them on the turbine deck or somewhere that is exposed to humidity and dust, or replace the parts on a more frequent schedule. Somebody's asking about HELPlightning. I will get out to you, Aaron, and give you more information on that product. Okay. Please, anybody else have any questions? What I'll do is I'll keep the room open for another 2 minutes until 1:05. And then if we don't get any more questions from then I will shut the room down. And while I'm waiting for more questions, just want to let you know that all of our training courses that we usually offer in our Houston facility and our Carlsbad facility in California are still on hold. We are waiting for each jurisdiction to give us the go-ahead to start doing those training classes again. What I will say is, when we start doing those classes, we are going to have a backlog. So if you are thinking about doing training classes sometime this year, then please think about getting your requests in soon, because we are going to be having a waiting list, because there are a huge amount of people who expected to come in April, May, and June who didn't get to come, and we do have a backlog. So if you're looking for anything to do with Ametek SCI, whether it's training, products, services, you can go to our website. Lots of good information on there. Our marketing team do an absolutely fantastic job of getting all the information out there, whether it's new products or new services that we provide. You can sign up to our social media presence and you'll get notifications when they happen, and it will keep you up to date on everything that's going on with Ametek. Here's another question. If you're operating a very critical plant where shutdown is not possible, we cannot call a service engineer, what are the training available in Asia for customers? Great question. At this moment in time, we don't have the ability to do training that is not in person. There is a large portion of our training that is hands-on, that shows you where everything is, how to do things, and we have not figured out a way to create maybe a virtual reality training platform or something that would allow us to train people who don't come to our facilities. It is something that we're looking into, and if we do find something, we will definitely let you know through social media and all that kind of stuff. But unfortunately, at this moment in time, we don't have a way of training people out of coming to our service centers. What is the latest technology in UPS HMI troubleshooting diagnosis? Actually, that came up. We have research and development meetings quite regularly here at Ametek Solidstate Controls, and it's actually kind of a buzzword in new equipment and servicing of equipment on how to implement interactive troubleshooting diagnosis into the UPS when it is manufactured, so it can try and trend failure rates and see when something changes within the UPS. It may indicate that something is going to fail in the future. That would be great if we get there. We don't have anything at the moment, but it is something that a lot of manufacturers are starting to look at now, and I know that our research and development team are looking into that. So great question, and I'm looking forward to seeing what that technology ends up being. I think it's going to be very, very exciting. Okay, I think that's about it. If you need to get in contact with anybody at Ametek SCI, you can go to our website, and the contact details will be on there. There's a 1-800 number. There is a general contact email address, and it will be directed to the correct person. If you do want to ask more questions, you can carry on putting messages in the chat bar. I will get an email and I get a log of all the questions that are asked. Also, you can send it to the email address on the website, and I will be sure to get back to you within the next week or so. So thank you for all the good comments that everybody's putting in there. I'm glad that you found the training valuable. Once again, please, if you get a survey, please think about things that you would like us to discuss at the next webinar. We really want to hear what you want to be taught. It's very easy for us to sit in our offices or our ivory towers and say what we think you need to be taught on or have this webinar based on. But it's far more interesting if we actually talk about things that you want us to talk about. So please be interactive with us. Please let us know what you would like the next webinar to be focused on, and we will do everything that we can to make sure we cover that in the next few webinars. So the next webinar should be in about a month's time. If you've signed up for this one, you will get an automatic registration into the next webinar, and it will give you all of the necessary notifications to let you know when it's going to be. So I appreciate your time. I know that's an hour out of your day that you can't get back, but hopefully it was an hour that you learned some stuff and was interesting. If you learn something every time, then that's all I aim for. So until next time, I really do appreciate your time, and take care. And I look forward to speaking to you in a month. Thanks very much.